Imagine sitting in a classroom in 2001, where students nervously approach the vast world of artificial intelligence. No heavy calculus, no dense programming jargon. Instead, Michael Negnevitsky flips the script, saying the core idea is surprisingly simple. But what if these straightforward concepts could unlock machines that learn, adapt, and think? That open loop, the mystery of intelligence made accessible, pulls you deeper into the landscape of intelligent systems. Expert systems sound intimidating, right? But here's the catch. Their magic lies in rules, not complexity. Negnevitsky guides you through these systems that mimic expert decision-making without needing a PhD in calculus. Back in the early 1970s, Mycin, a rule-based expert system, helped doctors diagnose bacterial infections and recommend antibiotics. It wasn't a robot genius, but a well-crafted set of if-then rules, sort of like a medical detective's checklist. Michael highlights this case to show how encoding expert knowledge can make computers incredibly useful. No rocket science required. Think of expert systems as that bartender who listens carefully and knows exactly when to pour a second round. Instead of relying on complex math, they just apply a chain of simple rules, much like following a recipe. This is knowledge engineering in action, turning expert brains into clear conditions and logical steps anyone can follow. The real payoff: these rule-based systems transformed decision-making from static info dumps into flexible, fast reasoning engines. Suddenly, you could automate expertise in medicine, finance, or engineering, freeing up humans for insights, not grunt work. It's proof that intelligent doesn't always mean complicated. What if computers could handle the messy, gray areas of human thought? That's exactly what fuzzy expert systems do, embracing uncertainty instead of fearing it. Negnevitsky turns fuzzy logic into a practical, almost poetic way machines get real-world nuance. Take the elevator example from the book. By using fuzzy logic, these elevators don't just react to button presses, they adapt, anticipating your needs like, she's in a rush, or maybe she's carrying heavy bags. This subtlety comes from dealing not in absolutes but shades of gray, letting machines make better gut-feel decisions. Picture fuzzy logic like jazz improvisation. No strict score, just flexible, insightful riffs on themes. Instead of binary yes-no answers, fuzzy systems harmonize degrees of truth, enabling machines to juggle ambiguous data, much like how a musician gracefully navigates unpredictable melodies. The result? Systems that don't freeze up in uncertainty but get smarter navigating it. Fuzzy expert systems make your everyday devices and tools more intuitive and effective, turning mathematical fuzziness into crisp, real-world benefits. Neural networks and evolutionary computation sound high-tech, but Negnevitsky strips them down to their roots: nature-inspired learning and adaptation. Picture a forest of simple neurons growing smarter with every challenge. Negnevitsky explains neural networks by pointing to the brain's own wiring, a tangle of interconnected neurons learning by strengthening or weakening bonds. Universities worldwide tested these models in courses, demonstrating how simple digital neurons can collectively determine patterns, from handwriting to stock trends, without complex formulas up front. Evolutionary computation takes the survival of the fittest principle and applies it to problem-solving. Countless solutions compete, mutate, and evolve, improving over generations. Imagine a coach nudging athletes toward peak performance, except here solutions evolve automatically, hunting for the best answers in a digital wilderness. The payoff is outstanding. These intelligent systems don't just follow a predefined path, they innovate, adapt, and sometimes surprise us. It's like watching machines grow creative muscles, proving that intelligence doesn't require perfect knowledge, just smart adaptation. Back in that 2001 classroom, the buzz wasn't about equations, it was about possibility. Negnevitsky pulled AI from the ivory tower and planted it in everyday problems, showing you how expert systems, fuzzy logic, and neural networks form a toolkit to solve what once seemed unsolvable. Your takeaway: try spotting a fuzzy problem in your life where rules or adaptation can improve things. Because intelligence isn't magic, it's approachable and surprisingly human. Subscribe for more book summaries like this one.